Hi, welcome to my presentation. So the title of our project is Real-Time Purchase Prediction Using the Retail Video Analytics. This is a joint study with Anindya from New York University, Beibei from Carnegie Mellon University, and Kaiquan from Nanjing University. From the name of this project, we could tell that we incorporate the retail videos into analyses, and then we perform some analytics based on the video content, and then we build a prediction model to predict the purchase in real time. So basically, the major data source of this project is the video data. In the past years, researchers has been try to implement in multiple approaches to record the customer's behavior in this retail setting using such as the RFID tags, computer vision, wearable video cameras. And researchers found that there are various characteristics of customer demographics, their in-store activities, trajectories. All those factors could affect the customer's purchase decision. So basically, our study is sort of incorporate the video data to study the customer behavior in the retail setting. But the conventional previous research, all those approaches implemented in the previous research are not scalable nor automatic, and also they ignore the emotional response of the shoppers. So basically, our study sort of filling the gap between those two streams of literatures, and we want to understand the customer behavior of multiple dimensions, including the in-store emotion response on a scalable basis. Besides, we also build a predictive model of the customer's purchase decision based on the video data. This is a general context overview of the context in this study. So we collaborate with a large shopping mall from Asia, and they're very open to the AI technologies and willing to work with us for the research purpose. On the screen, we demonstrate the two plots of the store layouts to show the camera locations and also the store layouts. We can see that the CCTV cameras are placed in the key points, such as the entry, cashier, elevator, etc. And there is an example of the video data collected from the entry cameras. We can see that there are customers coming through the door, and the cameras could capture their face, their body, their motions, etc. And here is about 30 seconds of video clips collected from the cashier cameras. We could see there are like two female shoppers who are making purchase using their mobile phone. So what can we observe from the video? We can get the exact timestamp when the customer enter the store and when they check out. And we also could observe the trajectory and their in-store activities of each customer. And besides, we could get the facial expression of each customer. So as I mentioned before, we could observe the shopping behavior such as the entry, checkout, the interaction with the environment from the videos. We collected such information from January the 1st to January 23rd, 2020. This is still an ongoing process because we believe with more video data coming in, our results will be more robust and the prediction accuracy will be more higher. Besides, in the meantime, we also obtain the transaction data from the shopping mall. And then we could link the transaction data with the videos by a unique timestamp so that we could know which customers is buying what stuff at what time. And we also have the information of the products such as their name, category, price, discount, payments, etc. We collected over 20,000 records from over 6,000 unique payments. And this data set covers a wide range of product categories such as clothes, accessories, homeware, etc. To show you how we did the facial analysis, we first look at the videos collected at the checkout camera, and then we cut a 1-minute clip for each customer that covers their pay motion. So basically, this step is designed for recognizing the customers who made the real purchase, because in real life, people could line up by the cashier to wait for getting a purchase. In that case, it would be hard for the computer to tell which customers is buying what stuff at what timestamp. So in this case, we borrow some help from human coders and combine the human coded data with the state-of-the-art computer vision techniques to perform the facial detection and recognition. After we extracted the faces from the camera, we could perform a facial attribute analysis to get some features from their faces, such as the gender, age, emotion. Even we could extract their in-store behavior and others. Combining those features, we could build a profile for each pair. Similarly, we look at the video collected at the entry camera, and then we use the state-of-the-art deep learning computer vision techniques to perform face detection and recognition. Similarly, we build a profile for the non-pairs. Combining the pairs profiles from pairs and non-pairs, we get the video data. And then we could link the video data with the transaction data with a unique timestamp. To give you a brief sense of how the facial detection, alignment, and recognition process work, we first use a so-called multitask cascaded convolutional networks to perform face detection and alignment. So we could extract the human faces from the video. Next step is we perform a face recognition to distinguish the pair and non-pairs from the entry camera. So basically, in this step, we tried multiple packages and tools to extract the representations from the images, and then we could compare the representations of different images to calculate the distance, and then we pass the distances to a gradient boosting decision tree classification model to sort of get a sense of whether if this face has been shown before. So after this step, we could get the profile for the pairs and non-pairs. Eventually, we extract some useful facial attributes from those obtained faces. So we could get the gender, age, emotion, and other features. So there are two sets of variables that we're interested in order to predict their purchase behavior. The first set is whether if a shopper has paid or hasn't. So basically, in this case, we consider the non-pair as the baseline. From the data, we observe some interesting results. For example, compared to the male customers, the pairs are more likely to be a female. And also, the pair will have a older age and higher beauty score and higher health score compared to those non-pairs. And also, comparing to the shoppers during the weekends, the pairs tend to shop during the weekdays. And also, the sad pairs would be more likely to make the purchase compared to the happy pairs. If we use the total spending as the interest, the variable of interest, we could know that the male customers, compared to its female counterpart, the male customers tend to spend more. And also, the shoppers with higher beauty score tend to make, spend more in this shopping mall. And then during the holiday season, people also spend more. And people who with membership will spend more than the people who don't hold a membership. And for the customers who paid by card, those customers will spend more than those who paid by cash and by mobile phone. Based on our observation, we built a classification model to predict the customer's purchase behavior. So due to the time limit, I only demonstrate a binary indicator to indicate whether the customer has made the purchase or not to be the dependent variable. So basically, we pass the consumer shopping data to the classification model, and then we could get a high or low probability level of making a purchase. We used 80% of data to be the training set and 20% to be the holdout test set. And we tried multiple machine learning prediction models such as the penalized linear regression, random forest, KNN, decision tree, and the gradient boosting trees. Among all those prediction models, the gradient boosting trees performed the best. We also tuned the hyperparameters using the Bayesian optimization, and eventually we achieved over 90% on the test set. And in terms of results interpretation, we use the Shapley score to explain the prediction of an instance X by computing the contribution of each feature to the prediction. On the right-hand side, we show the feature importance on the aggregated level. The y-axis is the feature importance across different sets of features, and the x-axis is the contribution of each feature to the prediction. So we can see that the top three features are the gender, emotion, happiness, and the age. Those features are the top three features that contribute the most to the prediction. And the color indicates the high or low level of the feature value. For example, for gender female, being a female would contribute to the likelihood of making a purchase. Besides, we could also look at the results at the individual level so that we could explore the driving forces for the heterogeneous customers. For example, for this individual customers, we can see that being a female and having an older age would drive this customer towards making a purchase. But with the emotion being happiness, it would sort of drive the customers not making a purchase. This is not all of our story. We could also add more features to make our story more interesting. For example, to add the group shopping indicator to indicate whether if the shoppers have company or not. If the shoppers have someone to go shopping with, then we could calculate the group size. And we could also detect whether if the shoppers are parents with kids. Besides, we could also incorporate more video footages from different cameras so that we could draw a shopping trajectory for each customer. For example, we could even indicate whether if the customer has visited the dressing room or not. Besides, we also want to add the temporal dimension to our analysis. For example, we could explore how the dynamic emotional change could relate with other features. In that case, we want to introduce the state-of-the-art deep learning algorithm to make predictions, so we could include the temporal information to our results. Yeah, so this is all for today.